Afterwards, I moved to the European Space Agency, which
Hmm.
was kind of a blessing. It's pretty much a unique place on Earth where you have space operations for scientific missions. So it's about 20 missions every year, which are managed by the European Space Agency. So to say, because what we like on this podcast, I guess, is highlighting those European success. And we know NASA is first on the moon, JAXA is the first on an asteroid. This is the Japanese Space Agency, and ESA is the first on the comet, which is like mind blowing.
The first on the comet.
On the
What
comets.
does so? What happened
So
exactly? Did you land
so
something on the comet?
yes, it's the Rosetta Mission. So the Rosetta Mission was composed of an orbiter, so to say, so a big satellite which was holding a little bot which was called Philae, and it was pushed onto the comet, so it landed on the comet. I mean, upside down, but still we got data from the
Yeah,
comet, which is
that's
pretty
awesome.
crazy.
So were you able to then take samples from the actual comet and see what type of materials were? Or how did it work?
No, there were no sample returns. It was just like the remote sensing. So,
Mm.
so the challenge when you talk with the operations team, which I wasn't part of, but I was just following all those things, is that you always have a pre-model of the comet before you go. So you
Oh,
imagine your flight plan somehow. It's a 10 years flight plan where you go over, Earth, Jupiter, you accelerate, then you catch up, you slow down then, and then you catch up with the comet slowly, and then you get closer. As we were getting closer, we could see pictures, and it wasn't looking like nothing that the models were saying. So it was not like a big blob, it was like two different blobs with a little part in the middle. So you can imagine the gravity around the comet was very weird. So when you have to
mm.
orbit something, you really have to, you have a model of the gravity, but this one was totally different. So they really had to control the satellite very, very carefully
Yeah,
to orbit around. It was pretty much a
yeah.
challenge, solved, and it was crazy. Yeah, pretty crazy when you
Yeah,
think of
it
it.
sounds quite wild. And like a comet is moving at a steady speed, or is it changing speed as well? Like are there a lot of unknown
Yeah,
variables that you have to factor in
I
for
guess
actually
that's
landing on something
yeah,
that
yeah.
is moving?
Yeah, no, I guess that's the maybe the easiest part. I mean, so to say easiest is the
Mm,
trajectory of the comet. Is it was well known, so that's why like mission could start 10 years before reaching really the point. That's what's happening with big missions like JUICE for Jupiter. It takes several years to reach Jupiter. For Mars, it takes 6 months if you launch at the right time. But that's the crazy thing of space. The time scale of things when you have to go there because we don't have those magic propulsion systems. So that's the thing. We do
yeah, yeah.
gravity assist. That's super nice.